If you're interested in building your own LED circuits, I'm going to try to give you some information you need to be successful. For my own personal use, I'll be building LED circuits to light up buildings for my HO scale railroad. But the principles I'm going to talk about in this video apply to any LED circuit, regardless of how you use it. When designing your LED circuit, there are three things you have to have. Number one, you have to have some LEDs. Number two, you have to have some resistors to limit the current through the LED. And thirdly, you have to have a power supply. Now you see I have a number of other things here. I have a PCB board. I have some potentiometers, this is a variable resistor. And I have these terminals, posts for use on PCB boards. It makes it easier to connect wires, or you can even use them for connecting resistors. Going to need some solder. Going to need some flux. I need a soldering iron and a digital multimeter is optional, but it is helpful. And you're going to want some wire. Now here I have some 26 gauge wire, which is kind of the sweet spot where the wire gauge is large enough where it's fairly easy to work with, but small enough that it's easy to bend and tuck and hide, and it doesn't take up a lot of space. .24 gauge wire is even easier to solder. The larger the gauge up to a point, the easier it is to work with, but the larger diameter wire can cause some problems simply because of its additional bulk. And here we have some 28 gauge wire, which isn't my favorite to use. But you can see there's still quite a bit of stranded wire here to work with. When you get below 28 gauge, it really gets difficult to use, simply because there's just nothing to solder to. So I wouldn't go below 28 gauge. 26 gauge kind of seems like the sweet spot. It depends on how much current you're going to flow through the circuit. Now you're going to need a DC power supply. And for building LED circuits, I would recommend a minimum of 5 volts and a maximum of 12 volts. So anything in between that will work. Now here I have a 9-volt power supply, which is a wall wart. And if you have a small shelf layout, like a 8-foot shelf layout with 3 or 4 buildings, this would work great, because this has a 1 amp output, which is enough current to probably light up, 30, 40 LEDs. So this is an option for a small layout. If you're going to apply power to a larger layout, you're going to want more current. Now this is my bench power supply. I use it for mocking up and doing projects on my workbench. Now it has a 2 amp 12 volt output and a 5 amp 5 volt output. So I would choose a power supply. 5 volts or 12 volts are the easiest to get, and you can get those on Amazon pretty inexpensive. And here I'm going to throw up a couple examples. Everything that I'm going to use here can be purchased from Amazon, which will make it easy for you. You can get everything in one place with one order and be done with it. Now, something to know about resistors, and you're going to want to pay attention to this when you're ordering your resistors. They come in different power ratings in watts. Now, there's 8th watt resistors. I would avoid those. Don't get any 8th watt resistors, especially if you're using 12 volts. If you're using 5 volts, you might be able to get away with it, but I would just not use them. I would not use 8th watt resistors. Now, these are 1/4 watt resistors. These are okay when using these with individual LEDs. Now, if you want to connect multiple LEDs to one resistor, then you're going to have to go up in wattage. Now, you can see these are 1/2 watt. And I also have some 1 watt resistors. Now, these are whoppers. And I can connect a lot of LEDs through one resistor. Now, when designing your circuit, voltage is important, but voltage is secondary. The most important thing when designing your circuit is the amount of current that you're going to put through your LED. Too much current and you'll destroy the LED. So we're going to set our circuit up with the proper resistor for the current that we desire. Now, I choose to put 10 milliamps through LEDs. I find that for my use, that's the sweet spot for me. Now, most LEDs are designed to handle up to 30 milliamps, but that's the ragged edge, and you're going to take a chance on destroying your LEDs. And for me, if I'm going to permanently install an LED in one of my model railroad buildings, or if you're doing some other type of project and you want to permanently install an LED, well, you're not going to want to drive it that hard because you have a potential of burning it up. So limiting the current to a value that'll let your LED live a long life is important. So when designing our circuit, we're going to go through all that, and we're going to calculate the values depending on how much current we want to run through our LED. When designing any electrical circuit, there's 4 things you need to know. You need to know voltage, current, resistance, and power. Now, this chart here is called Ohm's Law. Now, you can get one of these charts off the internet pretty much anywhere. If you do a search by Ohm's Law, OHMS Law, a bunch of them will come up. And just print one out, have this handy, put it in your toolbox. You can refer to it. And we're going to use this when we design our circuit. We're going to be referring to this to do our calculations. Everything you need can be found on Amazon. You can also get parts on eBay or wherever you choose to buy your parts. Most of the time, I get stuff from Amazon simply because it's easy. I'm going to put up some screenshots of different parts that you might want to consider. The first circuit we're going to set up will be using a 5-volt power supply. So the first thing we need to do is we need to calculate our resistance value. We know our voltage. Our voltage is 5 volts. We know our desired current. Our desired current is 10 milliamps. So we're going to run 10 milliamps through the LEDs, because that's a safe current, and they'll live a long time. So we take voltage, 5 volts, divided by 10 milliamps, and our resistance value is 500 ohms. All right, I have some 500 ohm resistors here. Now these resistors aren't exactly 500 ohms. But for the amount they vary from 500 ohm is going to be inconsequential. But we'll measure it, and we'll do a little exercise. So I'm going to take the multimeter, set the multimeter to ohms, and we're going to measure the actual resistance of this resistor. All right, so its actual resistance is 514.8. Now we're also going to measure the output of our power supply. And you can see the output is 5.015 volts. All right, we know what our values are for calculating our current. Our voltage is 5.015 volts. Our resistance is 514.8. And so our current is 9.74 milliamps. And that's close enough to our 10 milliamp target that we're just going to go ahead and run with that. Now, when you buy a power supply, if it's non-adjustable, it's a 5-volt power supply without any adjustment, it's going to be close enough to 5 volts. And if you buy some 500 ohm resistors, now in the example we have here, we measured our resistor, it was 514.8. It's close enough. It's close enough to 500 ohms that if you don't have a digital multimeter, you don't need to worry about it. It's going to be close enough. Even if you do have a digital multimeter, don't sweat it. It's close enough. Okay, now before we solder up our circuit, there's one last calculation we need to make. And we need to know if our resistor can handle the power. Now we have our 1/4 watt resistor. We know the voltage. It's 5.015 volts. We know the calculated current, 9.74 milliamps. So the calculated power through our circuit is 48.8 milliwatts. Now our 1/4 watt resistors are good for 250 milliwatts, so we're way good. We're at less than 50 milliwatts through our circuit, and we have a 250 milliwatt resistor. So we're not going to have any trouble with this circuit, and we're not going to burn our resistor up. All right, so let's put our circuit together. I'm going to use our PCB board. And we have an LED. We have our 500 ohm resistor. That's actually 514.8 ohms. Close enough. It'll work. And we're going to use this screw terminal just to make connecting the wires to the power supply easier. I don't have to solder and unsolder stuff. All right, I'm going to take this little screw terminal here. I'm going to put it through this side of the PCB board. That way I can solder the legs to the copper on the other side. I'm going to use a micro brush for applying flux. So just get a little bit of flux on the micro brush. Then apply the flux to the legs of the screw terminal and the PCB board. All right, I'm using this spool of wire just to hold everything down. I'm kind of working blind here. All right. So we got that soldered in place. Now with our little screw terminal here, we're going to need to decide one side's going to be positive and one side's going to be negative. So just going to make a mark on this side, and that is going to be our negative side. All right, so looking at the back of our PCB board here, I put a little mark here, so I know this is the negative side. Now you can see there's a copper run that runs all the way to the length of the card. So this would be all negative, this would be all positive. When soldering up our LED, the long leg is always the positive leg. So when we solder it into our board here, we want to make sure we have the positive leg to the positive side. All right, I bent the LED legs to be able to place them into the PCB board. And you can see I've also marked the negative side of the LED. So after bending the legs, it might be difficult to tell which is the long one and which is the short one. So what I'm going to do, I'm just going to place this into the PCB board. And now I'll go ahead and solder this in place. Add a little bit of flux. And I got this weight here just to kind of hold everything in place. All right. All right, so I have the resistor in place. Now I'm going to solder it on the other side of the board, but I just want to show you on this side how the current's going to flow. So this is the positive side. Now we can have the resistor on the positive or the negative side. It doesn't matter as long as it's just in the circuit. And a resistor doesn't have a positive or minus side. You can put it in either way. It doesn't matter. Now this is our positive side. And so our current flow down this strip through the resistor into the positive side of the LED, through the LED over to the negative side. So that's our current path. All right, so I'll go ahead and solder in the resistor. Okay, so we have our current path. This is the positive side right here. Our current path is here to where it enters the resistor. Resistor comes across here. Now you can see where there's 3 holes in the copper strip right here. So this part of the resistor and the positive leg of the LED have continuity. So now our current's going to come down, go through the resistor. Our 500 ohm resistor is going to set the current to 10 milliamps. It's going into the positive side of the LED, through the LED, out the negative side to the negative side of the power supply. So let's wire it up and give it a try. Okay, so I went ahead and attached the wires here, and I've attached them to the 5-volt power supply. So I'm going to go ahead and plug in the power supply. The power supply doesn't have an on-off switch. All right. And you can see with 10 milliamps of current running through the LED, there's plenty of illumination. And with 10 milliamps of current through our LED, we know that this LED is going to last a long time. It's going to last years and years. With the resistors I have on hand, I'm not really set up to run a 12-volt system. And this is my selection of resistors. I don't have any 1200 ohm resistors. But what I do have is a 700, a 300, and a 140. And so I've just soldered all those together to get me 1140 ohms, where our target resistance value would be 1200 ohms. So the nominal resistance value for those three resistors is 1140 ohms. But we want to go ahead and measure that. Okay, we have our multimeter leads connected to our three resistors we have soldered in series. And nominal resistance for these would be 1140 ohms. We'll set our multimeter to resistance. And it reads 1192 ohms. So that's almost perfect for a 1200 ohm target using a 12 volt supply. Now, using Ohm's law to determine our current, our nominal current would be 12 volts divided by 1200 ohms would give us 10 milliamps. So now I want to measure the output of my 12 volt power supply. So what I want to do is set my meter to DC volts, turn on my power supply, and the output is 12.35 volts. Before we solder up our 12 volt circuit, let's use Ohm's law to review everything. I'll start at the beginning. And we want to calculate our resistance value. And so we have a nominal voltage of 12 volts with a nominal current of 10 milliamps. Now we don't know our exact voltage yet, and this is our target current. So we're going to take 12 volts divided by 10 milliamps, and we're going to come up with 1200 ohms for our target resistance. Now we measured our 12 volt power supply, and it measured at 12.35 volts. We measured our resistance, which came up to 1192 ohms. And so our actual current through our circuit is 10.36 milliamps. So we know the exact current flowing through the circuit. We have a target of 10 milliamps. Our actual circuit current is 10.36, which is pretty close. And now we got to calculate our power to make sure our resistance can handle the power going through the circuit. So we take our voltage, 12.35 volts, times 10.36 milliamps, and we came up with a power of 128 milliwatts. Now 128 milliwatts is less than the capacity of a quarter watt resistor, which is 250 milliwatts. So using a 250 milliwatt resistor in this circuit, you have plenty of overhead and you're not going to burn the resistor up. Okay, before I solder up the 12 volt side of the PCB board, what I need to do is cut this trace for the negative side, cut the trace for the positive side. So I'm going to cut that about right here because I don't want the 5 volt and the 12 volt interacting with each other. So I'm just going to take a X-Acto blade and just cut across this trace and separate these. All right, so you can see that I've cut the trace here. And so the 5 volt and the 12 volt circuit are separated. All right, so solder this up. All right, so solder the resistor in place. Well, it's a good thing I double checked because I soldered the resistor to the wrong side. So let's see if I can get it right this time. All right, as a demonstration, I changed things up this time. Now, the important thing is that the resistor is in the circuit. It doesn't really matter which side of the circuit it is on, positive or negative side. So this time I put it on the negative side. So this is the positive side. So we're coming into the LED. There's no resistor or anything in between the input from the power supply and the positive side of the LED. We go across the LED to the negative side of the LED to the resistor, where the resistor here is soldered into the negative run. So we got positive to the positive side of the LED, over to the negative side of the LED, and this time we have the resistor on the back side of the circuit. So here's the resistor across here, and then back to the negative side of the power supply. It doesn't matter. The resistor just has to be in the circuit. It doesn't matter where in the circuit it is, the positive side or the negative side, before or after the LED. All right, we're all wired up. This side of the circuit is connected to the 5 volt power supply. This side of the circuit is connected to the 12 volt side of the power supply. So go ahead and plug this in and see how it looks. All right. Now this side on the 5 volt, we have 9.74 milliamps. And this side on the 12 volt, we have 10.36 milliamps. And you can see the illumination between the two LEDs is very similar. So it just shows you we're limiting the current to 10 milliamps, approximately, nominally 10 milliamps through each side. This side 5 volts, that side's a 12 volt. The voltage is secondary to the current. The current flow through the circuit is the most important thing. Now there's something I want to talk about here, and this is important. Now if you go on Amazon, you'll see there's some LEDs that have the resistors already soldered on and have the leads already soldered on. Well, when you're buying something like that, I mean, it's okay to buy something like that as long as you know what you have. Now this LED right here, with the leads and the resistors already soldered on Amazon, it says it's good for 12 volts. Well, you see the resistance value is 429.3 ohms. All right, I'm going to put the Amazon listing up here quick so you can see what I'm talking about. And this is the LED. Now, I would not use that in a 12-volt circuit. Even though the Amazon listing says it's for 12 volts, it is not for 12 volts. Now, here's where Ohm's Law comes in to save us. So we want to know what the current is through the LED. We know our voltage, 12 volts. We know our resistance, 429.3 ohms. The current is a whopping 28 milliamps. 30 milliamps will usually damage or destroy an LED. And the calculated current for 12 volts is 28 milliamps. That is way too close to the edge. And on top of that, the listing says they're using a 1/4 watt resistor. So if you calculate power, got the voltage, 12 volts, we know the current, 28 milliamps, we come up with a whopping 336 milliwatts pumped through a 250 milliwatt resistor. Well, that resistor is not long for this world. You're going to burn that sucker up. Now, if you use that pre-wired LED with the 429 ohm resistor, now if you use that in a 5-volt circuit, you got 5 volts divided by 429.3 ohms, and you come up with 11.65 milliamps, which is a little higher than our target of 10, but, you know, we could use that. It's okay. And if you calculate the power, 5 volts times 11.65 milliamps, you come up with 58 milliwatts. Now, 58 milliwatts through a 250 milliwatt resistor, you're good all day. So the LED with the pre-wired resistor and leads is fine for 5 volts, but the listing says it's for 12 volts. So you have to check. If you buy an LED and it comes with resistors, don't just take it for granted that what they give you is going to work. You need to calculate it and figure it out. All right, well, there's a lot more we could do here, but this video is getting pretty long, so I'm going to end it here. I hope this was helpful to you. I hope you got something from this and you want to go out and design your own LED circuits. There's a lot more we can do with this, but this is the basics. And this will get you somewhere. So I want to thank you for watching, and I hope you come back and join me again.